Example 2 says, let's say we have an equation with equal roots. So the equation x squared minus kx plus k plus 3 has two real and equal roots where k is a constant. It wants us to not only find the possible values of k, but then afterwards it says, hence, for the smaller value of k, find the roots of the equation. So we've got several steps here. So first thing that I need you to understand is that you're giving information here, and so that information is very critical in any math problem. So the first thing says quadratic equation. So what do we know about quadratic equations? Well, they should be in the form ax squared plus bx plus c equals 0. Now our equation is written as x squared minus kx plus k plus 3 equals 0. Pretty similar, but it looks a little different, okay? Now, what you're going to be asked to do in some of these problems is make a connection, okay? So, when we see here that a is the number of x squareds, well, how many x squareds do we have? There are one of them. Perfect, okay? So we know that over here we've got a is going to equal 1. Then we see b is the number of x's, or the number of single variables. It could be different. Now, if we look here, how many x's do we have in the blue equation? We actually have negative k of them, right? So it doesn't matter that that's a constant. We're just going to keep going with the problem. So right here we've got b is negative k. And we're going to use this information to help figure out stuff later. And then lastly, one thing that can throw people for a loop, c is whatever's left over. Now, what's left over in the blue equation? Well, it's k plus 3. Now, k, remember, is not a variable. K is a constant number. We just don't know what it is. Think of it like pi. You know, we can't, pi plus 3, pi plus 3 is easier than having to write 6.141592, whatever, forever. So we just use pi instead. So we're just using k. So in this case, c is what's left over. That is k plus 3. So that's okay for it to be multiple things. We're just identifying what each parameter part is. So now we could go forward and kind of help figure out this problem. So different values of k could give us different things, but for whatever reason k is a constant. Now the other piece of information that it gives us is that we have two real and equal roots. Let's think back. What does that mean? If you know that you have two real and equal roots, that means something about the discriminant. And specifically it means that b squared minus 4ac is going to be equal to 0. So that's what two real and equal roots means. It means that we're going to have a discriminant equal to 0. Now, since we know what a, b, and c are for this particular problem, we can go ahead and use that. This is the scaffold for the whole problem. We're going to use the specifics and try to figure out what values of k can make this work. So we start off and say, okay, well, b squared. Well, b squared is negative k squared. Okay? Now, we then take negative 4. That's there. A is 1. Now, c is k plus 3. These are two things that are together. Right? So we have to place them together like that. And we know that the specifics of this problem mean that the discriminant has to be 0. So we set that up. Now we have an equation that we can work with. So your goal in part A is to find the possible values of k. You now have an equation that you can do that with. So let's keep going and see what we do. So negative k squared is going to be k squared. That is the same thing, right? Because a negative times a negative makes a positive. Always remember that. Now, when we go here, we're going to have negative 4 times 1 makes negative 4, and k plus 3. So we have negative 4 times k plus 3. So what happens here? Well, we need to distribute this negative 4 to each part. So negative 4 times k makes negative 4k. Negative 4 times 3 makes negative 12. And we get that to equal 0. So at this point, we have an equation. So you may say, well, this doesn't help me at all. Well, notice one thing about it. This equation here is actually a quadratic equation. Now you have a bunch of different ways that you can solve this. You could do the quadratic formula, you could factor, you could do completing the square. Whatever it is that you choose is fine, as long as you follow through and make sure that it applies. That's it. You can even graph it and figure it out. But this is a quadratic equation, so there are those methods that we looked in the flashback to help figure this out. So a method that I like to do, especially when you have nice clean numbers, is factoring. Factoring doesn't always work, but it's a great skill to learn and practice, so I suggest give it a shot sometimes. Again, quadratic formula also works. So what I'm going to do is figure out, okay, if I factor, I'm going to set up my binomials. I'm going to sit there. So I look at my first term, I get k squared, so which means I'm going to more than likely put k and k here. Now I need to figure out, because these are single k's, what two numbers multiply to make negative 12 that add to make negative 4? So what are those going to be? Negative 6 and a positive 2 would accomplish that goal for me. So I'm going to go ahead and leave that. And this tells me that if k minus 6 times k plus 2 equals 0, then either k minus 6 equals 0 or k plus 2 equals 0, which means that k is either going to be 6 or k is either going to be negative 2. So these are two specific ways that could happen. If k was 6, we would have two real and distinct roots, or if it was also k was negative 2, it would work. So what B tells us, it says, hence, for the smaller value found in A, so our smaller value of k is negative 2, find the roots of the equation. So what we need to do is actually go back and substitute the negative 2 in for these places. So where does this apply? It applies at the negative k and this part here. So we're going to go ahead and plug these in. So x squared stays the same. We then have negative kx. So the opposite of k would be a positive 2. And then we have k plus 3. K plus 3 is negative 2 plus 3, which is going to be a positive 1. And that will equal 0. So at this point, we should find that we're going to get two of the same roots. And we want to figure out what are those roots going to be. Well, you can go through, this is a quadratic equation, you could use factoring, quadratic formula, completing the square, whatever it is that you choose is fine. I'm going to choose to factor again. And so at this point, I'm going to set up my brackets, or parentheses, and I'm going to figure this out. So we've got x squared to start, so I'm going to put x here and an x here, and I need two numbers that multiply to make 1 that add to make 2. And they should be the same because these are two real distinct roots. I get that those are going to be the number 1. And so at this point, I know that either x plus 1 equals 0 or x plus 1 equals 0. And we find that x is going to equal negative 1 in both of these cases. So for each of these parts, now this is for k equals 1. Okay, or k equals negative 2, not for the other part. But we find that if k is negative 2, we do get the same root twice. And that's because the discriminant is 0. All of these things tie together. So the big key to many of these problems is, they may seem very vague and tough at first, but you have to take out the important information and use anything that you know to help you. And the big key with this class is definitely to set up that scaffold of how the problem's going to look. And it all starts with knowing what we know about the discriminant at the beginning.